in tornado forecasting. And then I sort of let that go and just dedicated it to, the places I travel to, the experiences I have, going wherever.
2011, that's a long time. That's a serious amount of record keeping.
Yeah, it's been fun. It's fun to look back on, everything that I've done, good memories.
See the progression. Kind of
Yeah.
check, oh man, I forgot I was down there.
Yeah, everything kind of it was kind of new and different and a little awkward at first, but I think it runs pretty smoothly now.
Had you had any experience writing or do anything blogish? Or
No,
that was kind of your introduction?
yeah, I'm always kind of behind the times, and when new stuff comes out, like Twitter.
You and me both. I
Blogging.
just joined Twitter a couple weeks ago. I'm way behind.
That's awesome. Yeah, I just joined maybe 6 months ago, so same boat.
Same, yeah. Did you, so that started out of the tornado chasing you're saying, or tornado watching?
Yeah, I went to the University of Nebraska, and lots of tornadoes out there, and that was my thing. That was the thing that got me into meteorology. So the blog was kind of documenting storm chases and maybe some research on the side, into how to forecast those kind of events. And then I got into hiking, mountain climbing, stuff like that, and I sort of just dedicated the blog to, adventure.
The University of Nebraska, you went there to be a meteorologist?
Yeah.
Okay.
Yeah, I started a little late, age 21. I couldn't figure out what I wanted to do, but
I think a lot of people can relate to that.
yeah.
Like, I don't know what I want to do. And then you go to college and you're like, I guess I'll switch majors 5 times to figure it out.
Exactly. I probably did that. Yeah.
What did you start with?
Well, I got out of high school and I thought maybe criminal justice at first, but I discarded that pretty quickly, and then I sort of just bummed around and then figured out, I love weather. I love severe weather especially, so yeah, I'm going to go to college for that, and I was pretty psyched about it, pretty inspired by that, and I just did it and got a job with the National Weather Service after that, and yeah, made a career out of it.
That's pretty crazy.
Yeah.
It's hard, I would imagine, to see a tornado and not just think, holy shit, what am I watching right now?
Yeah, they are amazing. The only thing I can compare it to would be like watching the aurora or a volcanic eruption. It's just sort of, it's a different kind of energy, really in your face example of, the power of Mother Nature. Very dynamic, very beautiful, but violent. Just a lot of things mixed together. It makes it out to be a very unique experience when you do get to see one.
Yeah, I've never seen any of those in real life, but I've seen a lot of videos, which obviously don't compare, but it's insane. And especially with technology today where you can see those without actually being there.
Yeah.
And just think, holy shit, I'm glad I'm not in the path of this tornado or in the path of this hurricane right now.
Yeah, it's pretty crazy that we could just sit back, here in California and watch a live stream of somebody chasing a tornado in Oklahoma. I think it's pretty neat.
Or getting blown around by, 70-mile-per-hour winds.
Yeah.
That just thrashed in the street. And you're thinking, oh, that's not where you want to be.
Exactly.
Did you know when you were there that why meteorology? It was just the weather. You were just fascinated.
Yeah, I lived out on the East Coast for a while. My dad was in the Navy, and then he got stationed at Offutt Air Force Base in Nebraska. And just, going through all the seasons, the violent, severe weather during the spring and summer, and then the crazy winter storms, blizzards, just the very, dynamic nature of those experiences inspired me to go into meteorology. And I especially wanted to study tornadoes. I was just fascinated with how they work, forecasting them, and like seeing the storm chasers and the researchers go out into the field, and observe them and measure them with radars and whatever. It seemed like a really cool career potential.
I'm envisioning that one Storm Chaser movie from like the 80s or 90s where it's a guy and his crew and then he runs into his ex-wife and they're chasing these tornadoes. I
Yeah,
can't think of the name of it.
Twister.
Twister, yeah.
Bill Paxton.
Great movie.
Yeah, I love Bill Paxton.
Is that kind of accurate still today with how they're monitoring tornado? Obviously, there are still tornado chasers, but is it still that same kind of tech or pathway?
There's Hollywood has, I don't know, maybe taken some liberties, but in general,
To say it lightly,
yeah,
taking some liberties.
I think it gives a good feel for how a storm chase goes down. That's pretty much what you would experience if you were, storm chasing down in Oklahoma. Kind of how that all went down. Now, people don't throw their vehicles into tornadoes to measure, the tornado. Although, actually, there are a couple of armored vehicles that actually try to drive into the path of a tornado, so I take that back. That's pretty crazy.
And they managed to stay on the ground, or are they just
Yeah, they have
insanely heavy, or
they're very heavy, and they have like these spikes that will go down into the ground to hold the vehicle in place if a tornado happens to pass over. So yeah, believe it or not, that exists.
that's pretty insane.
Yeah.
Is that how you guys are getting your information? So if you're monitoring a tornado or you guys are watching the weather to see it's tornado season, are you relying on tornado chasers to kind of feed you that data? Are you guys looking at satellite images, or how are you guys monitoring that?
The greatest tool is the Doppler radar, but we'll take in, reports from storm chasers. It's always great to have like eyes on the storm, It kind of confirms what you're seeing on the radar. But the radar is by far the greatest advancement in tornado warning outcomes. Many lives have been saved because of the warnings that we send out via, what we're seeing on Doppler radar.
This is going to sound like such a lame question. Is the Doppler radar, is that little thing that looks like it has two balls spinning on the end?
Ours is up up kind of in the foothills of the King Range above Ferndale. But yeah, it's just sort of that dome that looks like a golf ball. There's a radar within that dome.
How is that working?
It's sending out pulses of energy, and the energy hits, targets, like it could be insects or it could be raindrops or hailstones. Whatever's out there in the atmosphere, the energy will hit that, and then those targets will bounce the energy back to the radar. And the radar is measuring basically how strong that return signal is.
And how do you extrapolate that information for a tornado?
So we see the distribution of precipitation within the storm, and then we can also see the wind direction, actually the wind speed within the storm as well. So we can see rotation through the Doppler radar. And certain rotational patterns will tell us, there's a high probability of a tornado. And then we just sort of draw a box around what we're seeing on the radar and then send out the warning.
All just based on the data that's being bounced back to you guys by what it's hitting and
Right.
reflecting off of.
Yeah. It's just basic send out a pulse of energy, it hits something and it bounces back to the radar, and then,
When you say pulse of energy, is it like a radio wave?
it is, I think is it in the microwave spectrum? I'll have to look that up. Yeah. It is, it's similar, to a radio wave.
That's pretty insane.
Yeah, it's a great piece of technology. It's a huge advancement, saved many lives. We have other things available too, like you said, satellite and model data, but radar by far is the best way to identify these dangerous storms.
Is that true for weather in general, or just something like a tornado where you can bounce it off?
Yeah, we look at, anything, any object out there, in the atmosphere, we'll send a return signal back to the radar. Crazy thing, like when Columbia disintegrated over Texas, the radar picked that up. Um, that was back in the early 2000s, I think. Yeah, anything out there, the radar will see.
What is the what's the accuracy for these things? I mean, are you mapping them like a grid so you have one spaced out every, X amount of miles, or do they have a pretty far range?
The signal becomes weaker as you go farther out from the radar. So I guess things become a bit degraded. The farther away from the radar, you are bouncing those waves of energy off of. So the closer an object is, like a storm, to the radar, you'll see more detail. Whereas things get kind of smeared out farther out from the radar.
So if you're in Nebraska, are they placing these in specific locations where tornadoes have happened, or just close to cities, so that obviously you can alert people and say, hey, something's coming down the pike?
Yeah. Each National Weather Service office generally has a radar. It may not be right at the office. It could be, I don't know. Ours is, obviously out there in the King Range, so it just depends on the office, but usually each office will have a radar associated with it. And then there's FAA radars at airports. Of course, TV stations have their own little radar. Some universities have a research radar. So there's lots of radars, but the primary radar for warnings is the National Weather Service array of radars, spread out across the nation.
How would they alert people prior to the Doppler radar? Was it just, it touches down and people see it and start maybe like a warning alarm?
Well, there were other radars back then, but they are nowhere near as good as the radar that we have available to us now. But meteorologists have access to cruder forms of radar back in the past, say the 50s, 60s, 70s. And then word of mouth, I heard a tornado was located here and the storm was moving this direction. And I guess those two methods would be, probably how they issued warnings. I can't say for sure back then, but
yeah, that latter method doesn't seem that great.
Yeah,
just hey, I think there's a tornado touchdown over in this town. Probably don't go that way.
Yeah, really, the warning system before Doppler radar was
not great.
Not great, and there are a lot more fatalities during these tornado events as a result.
How far out can they be determined that it's actually happening? I mean, are we talking not days in advance, right? It would be hours. Are we talking within an hour?
The Weather Service has a system called Outlook Watch Warning. So basically, we can issue an outlook that, this Thursday looks really good for tornadoes. So we just kind of circle the area that has the highest risk and then type up a discussion and say, be on the lookout, on Thursday or Friday or whatever. And model data allows us to, look out into the future and determine that. And then the watch is issued, say, 8 hours before the tornado, saying during the next 8 hours, this area is going to be under the gun, so be on, extra alert during this time period in this area because tornadoes could form, during the next couple hours. And then the warning is like right now.
It's happening right now.
We're seeing it in the radar, or we've got a report and we're going to issue a warning, and you have to take immediate action if you're in a warning. So that's kind of the system that we follow in the United States for getting the word out for tornado events.
Do other countries have tornadoes?
Yeah. Not as many as the U.S., but
I've never actually thought about that until right now.
Yeah, Europe, they have tornadoes. England, Australia gets tornadic storms. South Africa, down in South America, Argentina, that area. Basically, any place that is downwind from a north-south oriented mountain chain creates these weather systems that can be favorable for tornadoes.
Is it just the wind coming off of those mountain ranges and then it creates some sort of vortex
Yeah, they
as it
create
passes through?
low pressure systems, cyclones, and the cyclones create, frontal systems that lead to thunderstorm initiation, and then you also get strong wind shear with these storm systems, and usually they draw moisture into their cyclonic circulation, and then these ingredients favor tornadoes.
That's insane. Do you need to have when you're looking at the data and you're extrapolating out, say a couple days in advance, and we say, okay, we think there's going to be a tornado here. How are you guys drawing that conclusion? Are you looking at pressure systems? Are you looking at wind that is coming in and thinking, oh, there's going to be a lot of wind over the next few days. This looks like it's going to be prime conditions for a tornado.
Yeah, really, tornadoes, you need a thunderstorm to develop. That's an essential ingredient. And the thunderstorms that form in areas of strong vertical wind shear, which is a change in wind direction and speed with height, that causes the thunderstorm to rotate. We call that a supercell. And then within the supercell, usually you'll get a downdraft that sort of wraps around the area of rotation near the base of the storm, and it contracts around that area of rotation and that contraction leads to a strong vortex that we believe is how a tornado forms, although it's still uncertain.
That's how one really forms.
Yeah, that's the leading hypothesis.
Is it weird that we don't know how it forms?
It's just a puzzle that,
We haven't quite solved yet.
Yeah, but I'm sure someday we'll get there. Yeah.
Why do you need a thunderstorm? Why is that a prerequisite for this? It can just be really cloudy.
Well, I mean, you can get dust devils, on a clear sunny day that's hot. But you need the thunderstorm to sort of stretch the vortex into, a violently rotating column of air. The thunderstorm updraft is required to get that strong vortex. It just can't happen any other way that we know of, except for fire whirls. We had an example of, I think, what would be equivalent to a strong tornado form in the Carr Fire near Reading a few years ago. And it was very impressive. You could see it on radar, too. It looked just like a tornadic area of rotation within the fire.
Is there a difference between that forming versus a regular tornado? Or the conditions are the same because of the fire?
The fire leads to kind of the same processes. You get the strong vertical stretching of, there was some sorts of vorticity, some rotation that got stretched within the fire updraft, and that led to a vortex that was equivalent to a strong tornado.
How does that vortex form? I understand that the wind obviously coming down off the mountains, that makes sense to me, but how does it form this circular path and create the vortex?
The big question is, what's the source of rotation in the tornado? And we really haven't nailed that down.
And how would it constrict to be such a tight pattern? I mean, why would it not form a vortex that's, a couple miles wide?
Yeah.
Just slowly swirling around.
Well, it can. The entire thunderstorm is sort of, that example of a several mile wide rotating vortex. So it's how to contract that big wide area of rotation down into a small area of rotation. And as that contraction takes place, the spin increases, so it becomes much stronger as it shrinks. So we know we have a pretty good idea of how a thunderstorm rotates, so we know the source of rotation. But the big question is, what's the source of rotation for the tornado itself? And That's the puzzle that we're trying to figure out.
That's still a mystery.
Yeah.
And it's the updraft that kind of starts the initial phase of it.
Yep. Yeah, I think you got it. Yeah. The updraft starts the initial phase. It facilitates sort of a host. It hosts the tornado. So as long as the updraft can remain healthy and long-lived, then, the probability of a tornado occurring and being long-lived itself is greater as well.
What causes the initial phase of the updraft?
An updraft forms when basically, it's warm and humid here at the surface and cold and dry, 10,000 feet above.
Oh, it's just the heat rising and falling.
Yeah, it's just that process
Okay.
of buoyancy.
Okay.
Except it's a moist form of buoyancy, not dry. Moist means that latent heat is being released due to a phase change in water. So that's what's driving, the thunderstorm updraft itself is just that process of buoyant energy, buoyant air rising.
So is that moisture a requirement as well?
Yeah,
Needs some sort of moisture in the air.
need the moisture.
If it was drier, would that result in the dust tornado, the dust devil
Probably-
phenomenon?
Well, if it was dry, then you probably wouldn't get a thunderstorm itself. So
Yeah, that's a good point. You would need some level of moisture.
yeah, you're a natural meteorologist.
Well, I don't know about that. I'm just curious. So you have these tornadoes where the funnel doesn't extend all the way down. Is that still classified as a tornado if it doesn't touch the ground?
It has to be at the ground.
Why do some not reach the ground? Why do some come, incredibly close and maybe a funnel starts from the ground and goes up, but they never attach?
Yeah, and that's another mystery is does the tornado form from the ground up to the thunderstorm updraft, or does it form downward from the thunderstorm updraft? And it could be both. I think there's examples of both. But it seems like maybe it's more likely on most occasions that it forms from the surface and then attaches to the thunderstorm updraft above. So why does it stay aloft or, I guess one thing that's really detrimental to tornado formation is if it's cold and the air is really dense down at the ground, then tornadoes are unlikely to form because that air can't lift upwards to the thunderstorm updraft. So you would never get a vortex, connecting from the surface to the thunderstorm. So the air needs to be warm and humid near the ground. That's the favorable ingredient for tornado formation.
Is it the buoyancy aspect that leads you to believe that it's a ground up formation and not a top down?
I think it's the source of spin that probably makes it more likely to form from the ground upwards.
Source of spin, what do you mean?
It's the spin is located down at the ground, and then it somehow becomes reoriented so that it becomes attached to the thunderstorm that's riding overhead. It's again, these are all just hypotheses. It's like we've already mentioned, still a puzzle.
I didn't realize there was so much still up in the air about all this.
Yeah, it really comes down to it's just hard to observe. It's hard for our radars to observe. It's hard for our, various measuring devices. We just can't. You can't get in there safely, to measure these things. You can't be there at the right time, the right moment, the right place to measure them. Everything just has to be perfect to get a good measurement of what's going on. And we have models that simulate, these tornadoes, but we need to verify the model and see, determine how accurate its source of rotation is compared to the real world. And that's the challenge.
Is the technology, that's the hang up right now, is just you can't go out there and stake a camera to the ground because it's not going to be there when you come back?
Something like that. Yeah, it's just being able to observe it to the degree that we need to observe the source of rotation, where is that rotation really coming from? There's so many things going on in the thunderstorm. It's hard to place, instrument packages in all these different locations because there's lots of different leading candidates for the source of spin. Yeah. And if you want to completely sample the storm, you have to have a large armada of, mobile vehicles, probing all these different places in the storm. It's just very difficult logistically as well.
Would it be easier to go in the air and go up into the cloud system to monitor it as opposed to being on the ground?
Yeah, UAVs are being implemented in this research. University of Nebraska is one of them that's doing that type of research. Yeah, and they're looking at areas, like flying through areas of the storm that we wouldn't be able to touch from the ground, So that's seems very promising.
But I would imagine that is a nightmare in the same sense because you're flying through a thunderstorm. So it's not exactly like, oh, we're just going to go up in a hot air balloon and watch how this plays out from above.
Yeah, and there's FAA rules on where you can fly, that you have to strictly follow. So you can't just launch your UAV anywhere you want, And then there's, I guess, what's the other flying, the little...
The little drones?
Yeah, drones, flying drones or whatever. People launch those as well occasionally. They get really good video.
I would imagine that thing would not be stable anywhere near a tornado.
Yeah, I doubt it
That's a
would.
good way to lose a couple grand, sending that thing up.
Some people send their drones into volcanoes and get great video, but the drone, obviously melts. But it's okay.
What a great way to get some footage, though.
Yeah, it is great.
Is the source, it seems like the source of rotation is a big hang up. Is that kind of the first domino that has to fall for pieces to start coming into place?
Yeah, I think if we could figure out the source of rotation, where it's located within the storm, and how it's sort of how the geometry of that rotation is getting shifted around within the storm to make it favorable to produce a tornado. I think those things would be huge if we could determine that. And again, it may ultimately be many different sources of rotation, come into play for different scenarios. It's just a very complex, thing going on.
Do you have a theory or a theory that's out there that you kind of more align with?
I mean, there are theories that seem promising. Yeah, I mean, the general process, like the last couple, I think it comes down to like the final stage of the tornado forming is where we're uncertain. But everything leading up to that final stage, I think we have a pretty good idea of what's going on. So it's just sort of, we can't connect that last piece of the puzzle.
The final stage being the actual touchdown or the start of the rotation?
We know what's going on with like the start of the rotation at a broader scale within the storm. It's how the tornadic scale rotation is developing within that broader scale rotation, if that makes sense.
Well, that's what's fascinating is because we're talking about a thunderstorm, and so it's covering a large swath of land. What would determine where in that thunderstorm it forms?
So we know that the thunderstorm acquires rotation from the vertical wind shear in the environment. And then we know that a downdraft forms on the backside of the thunderstorm due to that rotation. And then we know that downdraft usually wraps around the rotating thunderstorm and contracts it. So is that what's leading to the tornado? Is that contraction of the broader scale rotation, or is there some area of rotation embedded within, say, the edge of the rain shield associated with the thunderstorm that is being ingested into that rotating thunderstorm base that's leading to the tornado. And then the downdraft wraps around that and reorientates that horizontal rotation into a vertical orientation, if that makes sense. And then is that what's leading to the tornado? We don't know.
Does a tornado form at the heart of the thunderstorm, or can it form on the edges?
Usually it forms near that downdraft that I just talked about, sort of the interface between the downdraft and the updraft at the base of the storm. That's a large gradient in vertical velocity. And so you got sorts of stretching associated with the updraft. But the downdraft can also tilt rotation into, it can kind of change the geometry of the rotation so that it favors what may initially be horizontal rotation into vertical rotation, and then that vertical rotation is stretched by the updraft. These processes are at that interface between the downward moving air and the upward moving air. That's usually the prime location for a tornado.
And you guys can pinpoint where that's taking place.
When we see, we can see the rotating updraft in the radar, and then we can see characteristics of the precipitation being produced by the thunderstorm, and then the rotation can change the shape of the precipitation into what we call a hook echo. And that hook echo is usually a pretty good indicator that, tornadic processes are ongoing within the storm. And we see that radar signatures combined with, the rotating wind field in the radar, and those are usually two good signals that, there's a tornado probably developing potentially.
What is a hook echo?
It's basically the rotating thunderstorm causes the rain to curl around the rotation, so that you get this hook shape in the radar rain field. And it's just a classic, radar signature associated with tornadoes.
And you can see that before the actual visual tornado forms. You would see that pattern start to occur.
You could start to see it taking place, yeah. The tornado may already be ongoing by the time the signature shows up, so... but there's other things going on in the radar that, you can identify and get some lead time, perhaps up to 15 minutes before the tornado forms or hits a location.
That is not a lot of lead time.
Yeah, if you're using radar, it's very much, what you see is what you get. Like you could go from one scan and it looks like a normal storm, and then the next scan, it's like, wow, we need to get a warning out now. There's other promising avenues, though. We have these high-resolution models that can simulate these rotating tornadic storms. And some weather service offices are using that kind of information to get up to an hour lead time, saying that this location has a particularly high probability of experiencing a tornado during the next hour based on these model simulations that we're running in real time.
And so we have mathematical equations that you can use to actually create these tornadoes, simulated tornadoes.
Yeah.
That's pretty insane.
Yeah. It's the science is fairly advanced. We have a good understanding of, most of the basic atmospheric processes leading to this stuff. It's just once you get down to the really fine scale within the storm, in trying to identify, there's just so many different potential sources of rotation within these storms. It's like, which one is, the smoking gun? And again, it comes down to we just don't have the capability to observe within, the real world where and what is going on.
So with a 50-minute lead time, your best advice really is to just hunker down somewhere, get into a basement.
Yeah, there's economic impacts with false alarms. You could issue an alert that says during the next hour, there's a pretty high probability of a tornado in this area. But does it make sense, for everybody to give up an hour of their day to sit in their basement and wait out, this virtual warning? I guess it could lead to loss of, productivity. There's issues with that that we have to be thinking about as well. So I guess there's trade-offs. With safety comes a trade-off in some other area that we have to give up.
Yeah, but the alternative seems a lot worse, right? Flying through the air because some tornado just whipped through town.
Yeah, you're right. Most of the tornadoes are, believe it or not, the weak tornadoes, well, I shouldn't say this. Most of them, if your car is oriented correctly into the wind, there's some chance that, an EF0 will just pass over and it'll shake the car. But
The way you said some chance, I'm not feeling very confident with that.
well, most of the tornadoes are very weak. The ones that we really have to be concerned with are, the strong and especially the violent tornadoes. Violent tornadoes produce most of the fatalities. They're very rare, but there's no doubt that they do by far the most destruction and, kill the most people, unfortunately.
Is there a determining factor between if it's going to be a weak tornado versus a strong one?
You can kind of see in the environment, violent tornadoes have a definite environmental signature that you can use to forecast their potential. Whereas the weak tornadoes, they're associated with very weak winds in the atmosphere and potentially, it could be very unstable, but if the wind shear is weak, then the tornado is probably going to be short-lived and weak as well. So it really comes down to the shear profile, what the winds are doing.
What the conditions look like.
Yeah.
What is the magnitude difference we're talking about when we're saying weak versus rough tornado?
I think a weak tornado would be associated with rotating winds of, I don't know, maybe around 70 miles per hour.
That's pretty insane.
Whereas a violent tornado would have, I think, winds upwards of 300 miles per hour.
That's a pretty crazy difference.
Yeah.
70 to 300 miles per hour.
Yeah, if you're in the path of a violent tornado, your only chance of survival is in a basement because just about any structure is going to be just wiped off the ground.
How does it not pull? I've obviously never been in a tornado underground bunker or anything. Are those sealed concrete rooms and they just don't get pulled out of the ground?
Yeah, those are really good options if you have one. People put them like in their garages out in Oklahoma, on the Great Plains. They work really well. And then, of course, some people have tornado shelters. Basements can be problematic because debris can fill in, that void. And if you're in your basement and your house gets ripped to pieces, then all that debris is going to, fall on top of you in your basement. So there can be issues with that. But still, it's definitely better than being on an upper level of the house.
Or being outside.
Yeah.
What kind of power are we talking about in a 300 mile per hour wind scenario? Lifting a semi truck off the road?
Trains. Yeah.
That would be a scary sight.
Yeah.
You just see a train get ripped off the track and start swirling around. And it will how high will that carry it up into the air?
I don't have any numbers in my head. But yeah, they'll definitely get pushed off the tracks, if not, lofted. But yeah, like trucks easily lofted hundreds of feet into the air. It's pretty crazy.
That would be a sight to see.
Yeah, the most powerful violent tornadoes, like the upper 1%, just the energy and power within that vortex is almost beyond belief. It's just incredible.
When you have these tornadoes that there's multiple in a specific area, what is causing that when you have 3 or so right next to each other?
Yeah. Again, it comes down to the sources of vorticity. You could have what's called a vortex sheet that a thunderstorm updraft is sitting over, and there'll be these areas of spin on this line, basically, that the updraft is located above, and the updraft will just stretch these vortices up into its, rising air column, and you'll get several, tornadoes forming at the same time, all along a line.
Are there usually multiple points where that vortex could form and it just doesn't in a normal storm? Or that's pretty rare to have multiple?
It's fairly rare, but you'll see it a lot, like especially water spouts. That particular mechanism is common, say, over the Florida Keys, tropical areas that see water spouts. They'll get these patches of spin forming along a line, and all you need is an updraft to just stretch them up into the air. And yeah, you'll get a line of, weak but very interesting looking, vortices.
When you have multiple like that, do you ever get multiple strong ones?
There was a case in Nebraska a few years ago where you had two very strong tornadoes ongoing at the same time, and they were separated by a couple miles, but they were both legit, strong, damaging, potentially deadly tornadoes. So yeah, it's been observed.
Does happen. It's just a little more rare.
Yeah. Yeah. Usually, what will happen in that scenario is you'll get one tornado, and it'll go through its life cycle, and then you'll get one sort of forming, usually trailing behind, and then it'll sort of rotate around the same path. And as one dissipates, another one will form, and that could go on for hours.
Do they ever converge and merge into one tornado?
Yeah, that's possible. Yeah. There's been examples like on May 3rd, 1999 in Oklahoma where you had one large tornado that was ongoing and then sort of a subvortice tornado developed off to the side and then it wrapped into the bigger tornado and merged.
Are they always spinning in the same direction?
It depends on, usually in the northern hemisphere, yes. But that's because the cyclonic spin is usually located underneath the strongest part of the updraft. So usually there's also an area of anticyclonic spin that's located within a weaker part of the updraft, so it doesn't become as strong as the cyclonic member of that vortex pair. So usually that's why we see most tornadoes in the northern hemisphere rotating cyclonically.
Jesus, there's a lot in there. I mean, I could easily see how you would spend a lifetime trying to research this subject just to figure out what is actually going on.
Yeah, there's a lot of people are passionate about this subject, and like I said, it's a great puzzle that keeps people entertained for decades.
A lifetime. Is
Yeah.
the thought process that if we can gain a better understanding of how these things are actually functioning, that we could prevent them in some way? Or it's just, if we understand them, then maybe we can increase our alert time and maybe save a few more lives in the process?
Yeah, I think probably saving lives through better warnings and watches and outlooks would probably be the best case. Preventing them, that would be very challenging.
Is that a realistic possibility somewhere in the future?
I'm not certain. There have been attempts to seed clouds in the hopes that the seeding process will weaken the thunderstorm, and by weakening the thunderstorm, that might preclude a tornado from forming. There's also been, decades ago, talk of like exploding bombs within thunderstorms. Maybe that would disrupt them. And somebody actually, I think, published a research article proposing that we build a Great Wall, which is
A Great Wall on the Great Wall of China?
a very tall wall that would block airflow from, moving north across the Great Plains, and that would disrupt tornadic, weather systems, which I don't know how serious that those authors were, but yeah, that's
So people are spitballing some pretty crazy ideas at this point.
yeah.
Did-
But
Did they ever try dropping bombs
I
That
don't.
seems like a crazy stretch. But I mean, would the science back that?
I'm not sure. I don't think it was really pursued very far. I've never heard of that actually being attempted.
Yeah, I haven't heard them dropping bombs over Nebraska or anything, or clearing out an area and saying, okay, we're going to test this here.
Yeah.
Might be tough to get the public on board with that.
Yeah, and it would be tough to target storms. You know, you'd have to have bombers everywhere ready to deploy, and yeah, it seems tough.
But so does the building a Great Wall. That seems equally as challenging.
Yeah, it seems a bit ridiculous.
And so your start is on tornadoes. Where do you shift from that? You realize, okay, I've had my fill. I'm going to go with the National Weather Service, and they pivot you to something different, or you're still working through tornadoes?
I'm actually still working on tornado forecasting research.
Really, out here?
Yeah.
Oh, wow.
There's a professor who just retired a few years ago from the University of Oklahoma, and I'm working with him. Yeah, it's something I'm still interested in, even though I'm out here in California. So
Does that make the research a little more challenging, where you've got this degree of separation from it?
no, all the data that one would need is available.
At your
anywhere.
fingertips, yeah.
Yeah.
What do you guys? Are there specifics to what you're researching in regards to tornadoes?
Yeah, we're looking at what environments favor tornadoes that travel a really long distance versus environments that produce tornadoes that only travel a short distance. And the distance a tornado travels is important because, one, you usually need a really strong or violent tornado to go a long distance. And also that produces a greater footprint on the ground, so there's greater potential to destroy buildings and, injure or kill people. So it's a very important, forecasting topic.
Have you guys drawn any conclusions yet from that?
Yeah, it's been fruitful. The wind profile really determines everything in regards to whether it's going to be a short track or a long track tornado.
Can you guys predict the tract?
Like the actual how far, and put an actual number to it?
Or not necessarily how far, but the general direction it's going to be moving?
Yeah, that's
that's locked down.
Yeah, pretty easy.
It's just the distance of how long it's going to be there,
Right.
and how long it's going to be there. That's still
Right.
a challenge.
Yeah, yep.
And most of that is just predicated on the strength of the wind.
Yeah, it's mostly the strength of the wind. You have to have an environment that's, if you want to get a really long track tornado, you have to have a very strong wind profile, but you also have to have an area of moist, unstable air that extends a great enough distance downstream to, keep the thunderstorm itself going and remain strong, for hours. Because if you run out of that moist, unstable air, 30 minutes downstream, then it doesn't matter how great the wind profile is, the storm's not going to survive, past that 30-minute point. So that's another factor.
What's the general lifespan that we're talking about here?
Usually, I don't know, 10 minutes. Most of the tornadoes are weak, short-lived, short track, and they don't last that long and they don't travel that far.
How far on average? 10 minutes is a pretty short time frame for that thing to move.
Yeah, 10 minutes, 10 miles.
So
Maybe.
a mile a minute is probably the average.
Yeah, I'd say approximately.
That's still pretty fast. A mile in a minute that's not a slouch.
Yeah. Some can be stationary though too, and others can move 60 miles per hour. It depends on what the wind profile is, doing.
You could have a stationary tornado for its full lifespan. It would just stay in that one spot.
Yeah, there's been examples of a tornado that lasted an hour and it didn't travel more than a few miles from its starting point, which is pretty crazy.
Yeah, that's interesting. And that's again just wind profile?
Yeah, the wind profile is such that it favored a strong tornado, but it didn't favor it to move, And during that entire hour, it continued to get this influx of moist, unstable air, so the storm remained strong, but it just sat there.
And so is it kind of just rotating around a certain point?
Yep, sort of just rotating around within the storm itself. but not moving downstream.
That's probably best case scenario, huh? Is you'd have a tornado that just plants itself in one spot.
Unless you're the farmer that gets hit
Yeah,
3 or
unless it's
4
on top
times.
of your house, then it's not great.
Yeah.
And it did that for an hour.
Yeah. Yeah, it's rare, but, that type of stuff's possible.
Yeah, it's an interesting phenomenon that we just accept as part of everyday life. You just have tornadoes. This thing just comes down from the sky.
Yeah.
Maybe tears up a few houses and then goes away, and then you're just, okay, we're back to life. Or we're rebuilding and then we're back to life.
Yeah, that's kind of how people out there in the Great Plains, southeastern United States, kind of approach it, I think.
Are they kind of desensitized to it in the same way that maybe we're desensitized to earthquakes back here?
I have seen people freak out in Oklahoma City, when tornadic storms begin to form and warnings go out, watches go out. People are it becomes a madhouse because they've been hit so many times by so many violent tornadoes that, they kind of go insane for a few hours. It's kind of crazy out there at times.
During a normal tornado season, how many are they anticipating touching down on average?
Usually a normal season across the United States is about 1,000.
1,000.
Yeah.
And a
Most of them are
majority of
weak.
those are weak.
By far, a majority are weak.
When people talk about climate change and its effect on the environment, they normally talk about hurricanes and how maybe it's influencing what category those are going to pan out to be or the frequency of those. Is there any effect from a changing climate on tornadoes?
Yeah, it's the big question is how going into the future will the wind profile change. If we get the wind profile in general is created due to it's hot near the equator and it's cold near the poles, and that change in temperature creates strong westerly winds. So if that difference in temperature decreases due to warming pole temperatures, then the winds will become weaker. If the winds become weaker, then that would suggest you would have less long track, violent tornadoes. And maybe a bunch of weak tornadoes, I don't know. But, weaker winds equals weaker tornadoes.
Is that being represented in the data?
I can't say for sure. This past year we had a lot of big events through basically, it's a very active spring at times. April was a big month for tornadoes out there in the Midwest and Great Plains and Southeast.
What's the typical season?
It shifts. So during the wintertime, it's usually the Southeast. Alabama, Mississippi are just magnets for really long track tornadoes during the cooler months of the year. And then also occasionally it'll extend north into, Kentucky and Illinois, even during December. But then when you go into May and June, the area of tornado activity shifts over to Texas, Oklahoma, Kansas, Nebraska, Iowa, Minnesota, and Dakotas. Occasionally you'll get big tornado events in eastern Colorado. But yeah, it sort of shifts with basically the jet stream. The jet stream migrates northward during the summer and then sort of shifts south during the winter.
And what is the jet stream? I have a cursory understanding of that.
It's, again, that temperature contrast between essentially the equator and the poles. So if you have a strong gradient change in temperature as you move north, then you'll get strong westerly winds developing within that temperature gradient. And that's, a jet stream aloft.
And how far back does our data on tornadoes go? If we were trying to extrapolate, okay, what is happening with an increasing general state of, the general temperature or decreasing polar ice caps,
Right.
How far back can we look at the data to see the effect on tornado formation?
Here in the United States, we have records of tornadoes going all the way back to, I guess, the earliest, days of this nation, or, the semblance of the nation, back when, I guess European settlers kept records of that type of stuff when, when something would impact Washington D.C. or one of the coastal cities or colonies or.
Could you imagine seeing a tornado for the first time back then? You just come to this new place and then something falls out of the sky.
Yeah, that'd be
That would be a
welcome to America.
come to Jesus moment. Yeah.
Yeah. But it was kind of a hit or miss, in terms of recording tornado occurrence back then. Now,
Well, especially in terms of data, right? They're not getting wind speeds or
right. Yeah, it's nowhere near where we are now. I think really we've entered the modern era of tornado record keeping with the development of the Doppler radar. Everything changed with that piece of technology.
when was that invented?
I mean, there's been research on it for decades and decades, but it wasn't implemented nationally in the United States really until pretty much, I think, 90s.
Oh, so fairly recently.
Yeah. I think we were fully covered by Well, there's a Doppler at just about every National Weather Service office. That sort of took place in the 90s. So there's still gaps in the radar coverage, and those can be problems, for detecting storms. It's expensive. You have to maintain it, the system, the radar. So we don't have complete 100% coverage across the United States, even to this date, but it's pretty good. It's almost fully covered.
And that's just a resource problem. The money and the time that it would take.
Yeah, there have been proposals to fill the gaps in the radar coverage with smaller, less expensive radars, even putting them on cell phone towers and covering the radar gaps that way. Yeah, and the FAA, they have their radars at airports. Those have been useful.
You guys can tap into those?
Some of them, yeah. Yeah, some of that's available.
I would imagine would they have more coverage than you guys? Because there's so many different airports?
I'm not for sure. I don't know if they're at every airport. They might just be at major airports. Because, we don't have one here at, Arcata, Eureka.
Oh, yeah. Oh.
And I worked up at Juneau, Alaska. There wasn't one there. Yeah. But it would be great to have even gap-filling radars here at the airports because, our radar is sitting at nearly 3,000 feet. So it's overshooting a lot of, what's going on right down here at the surface, across Humboldt Bay. So it'd be great to have, a little radar at the Arcata Airport.
What are you guys monitoring with the one here? Are you guys just monitoring weather patterns?
Yeah, anything and everything that we deal with. We get a lot of storms, a lot of thunderstorms, especially during, wintertime. When we get these cold weather systems moving across, they'll produce thunderstorms and a lot of small hail, So we're looking out for that kind of activity. During the summer, we'll get, strong storms over Trinity County, Mendocino County. So we're watching those as well. And we can see, wildfires when they become really intense and produce these big plumes. We'll look out for that on radar because that's usually a sign that the fire is becoming extreme.
Yeah, we've had a couple pretty bad fires.
Yeah. This year we had a really good wet season during the winter, so our vegetation is fairly moist and healthy. So it's and that was kind of the case last year as well. These have been two kind of consecutive somewhat low fire activity seasons.
Were you guys monitoring the one up in Del Norte?
Yeah.
As that was unfolding?
Yeah. I was actually gone when those started, but we were covering those from our office. And yeah, Del Norte is the one area that has experienced more drought-like conditions. So that's where most of the fire activity is occurring, which makes sense.
So when you guys are monitoring the thunderstorms, is it more in relation to that? You guys are kind of just watching the pattern to see if there's going to be any significant strikes or the
Yeah,
potentials for wildfires to take place.
yeah, that's huge. Yeah, but we will occasionally get a severe thunderstorm or two during the summertime. Again, mainly Trinity County and Mendo, and then yeah, that small hail that covers the roadways during the wintertime down here along the coast. That's important to identify in the radar as well.
Are you able to glean any information from watching the thunderstorms up here in relation to your tornado research, or they're just almost two different things, even though they're both thunderstorms?
Um, yeah, they're all related. Essentially, it's just differences, and it's more. The Great Plains are just more ideal for strong rotating thunderstorms, but we will get these smaller rotating thunderstorms out here along the coast, especially during, say, December, with these Pacific storm systems moving across the area. Definitely seen legitimate rotating storms, and of course we get a lot of water spouts. Can't really see those in radar; they're just too small and too weak. Occasionally, though, we've almost pulled the trigger a few times for a tornado warning as we get these strong, wintertime rotating thunderstorms offshore approaching the coast. But they almost always, fizzle out when they move on shore. So haven't pulled the trigger on a tornado warning yet for those, but there have been a few interesting ones.
What is the difference between, say, a hurricane and the formation of a tornado? Are those pretty similar in structure? It's just the location.
Hurricane is forming due to tremendous amount of heat being released off of a very warm ocean. And those form under very weak wind shear environments, which is the opposite of of where tornadoes form. So yeah, kind of different things. They both rotate though, so but the source of rotation for the hurricane is different than the source of rotation for a tornadic thunderstorm.
What is the difference in that rotation? Because when I think of a hurricane, I'm thinking similar patterns in that it's just rotating wind.
Yeah, I mean, the heat that's being released, it develops convection, tropical convection, and pressure, just sort of a larger area of low pressure develops due to that. And then I'm not an expert on tropical storms, so I don't want to delve too deep into that topic because I'll probably put my foot in my mouth. But you get this eye that develops within a hurricane, and that's an area of really strong, broader low pressure, strong enough that it's drawing air downwards from the top of the hurricane, and that's why you get all this clear air within the area of low pressure. But immediately surrounding that, you have very intense thunderstorm activity rotating around that low. So yeah, it's not hurricanes are not feeding off of the vertical wind shear for their rotation, whereas tornadic thunderstorms, they get their rotation from the vertical wind shear. Because strong shear almost always rips apart a potential hurricane, but a storm in Nebraska thrives off of that vertical wind shear.
And again, you have that difference in wind speeds.
Right, difference in wind speed and direction.
What are the is the idea of the eye of the storm, is that similar between those two?
The eye of the storm is just developing because air is being drawn downward. It's subsiding within that area of low pressure. The low is, so intense that air is forced downward through the center of the storm, and you get this cloud-free eye-like feature.
If you were in a tornado in the heart of it, would you be fine?
Um,
Or is that a myth?
oh, if you were in the middle of a tornado,
Yeah,
like in
at the eye
Nebraska,
of the storm.
Kansas.
Yeah.
Um,
I mean, is it as chaotic as the outside, or is there that?
it would probably be filled with a lot of debris.
That's a good point. Yeah, you'd be getting hit a lot
Yeah,
by stuff just flying through.
yeah. Yeah. I don't know. There have been like myths back in, some farmer looked up right through the middle of a tornado as it passed overhead, or stuff like that, which probably should be taken with a grain of salt.
Yeah, how reliable is that story? I've always envisioned, that same line of thinking where if you're in the middle of it, oh, you're fine. It's the challenge of getting into the middle of it that you're probably not going to make it to.
Yeah, probably won't survive it. It's like getting into a black hole. Yeah, you're probably not going to survive that
Yeah, who knows
process.
what happens with that? So what is the average diameter of one of these tornadoes?
They're pretty. Most of them again are weak, and so weak tornadoes are generally associated with small diameters. Like 30 yards is typical storm report for a tornado. Once you're getting up to say 100 yards, then probably the tornado is becoming a bit stronger. And then there have been documented tornadoes as wide as 2 miles, over 2 miles, which is just gigantic.
That's insane.
Yeah.
That is a huge tornado.
Yeah.
A couple miles, and is the wind strength the same from the outer perimeter as you go in, or is it getting more powerful?
Usually when you have these really wide tornadoes, there's lots of little sub-tornadoes embedded within the broader, bigger tornado. So the most intense damage is going to be with those smaller sub-tornadoes sort of rotating within the bigger tornado. Whereas when you get, smaller tornadoes, they're usually just one vortex. Although they can occasionally break down into little sub-vortex tornadoes rotating around that as well. But yeah, the big ones usually have multiple smaller tornadoes embedded.
Is there any variance in wind speed between that outer tornado and those inner ones?
Yeah. The bigger, broader tornado, it's intense, but the wind speeds are much more intense with those smaller scale tornadoes. And there's an example of storm chaser Tim Samaras back in Oklahoma and his storm chasing team. They got caught by a tornado near El Reno, and it wasn't the broader, bigger tornado that killed them. It was one of these sub-vortex tornadoes that wrapped around rapidly and picked up the car and threw it, and they died. So that smaller tornado is what got them.
I would have never guessed that. I always thought it was just one giant tornado. Is it visible to the naked eye if you're looking at it that you can see subtle shifts?
Yeah, you can. If it isn't, obscured by rain or dust, then you can pick out these smaller tornadoes embedded. Yeah.
And those smaller ones, those are the ones that are probably going to get you.
Yeah, they're, the wind speeds are much more intense, and really it's the change in the wind as the tornado moves across you that, will pick up the car and toss it, because you might be fine when the car is facing the wind, but then as the tornado moves across, the wind direction will change, and what was a favorable orientation for the car with respect to the wind becomes unfavorable all of a sudden, and the car will flip and fly.
Earlier you said that if you drove in a certain direction, you might be okay. Is that if you're driving into the rotation, you're probably going to be all right?
Yeah, if you're facing the wind with a weak tornado, it's possible that the car could likely ride it out
going with the wind
without being flipped. There's been cases of that occurring with weak tornadoes, but even that is, very risky.
Yeah, don't let that be your first choice.
Yeah. that's a survivable scenario potentially, but if you're in a car facing a tornado, that's kind of a deadly situation. You're much better off to get out of the car and find a ditch and get into the ditch, like a low point that sort of sags below the horizon so you don't get hit by debris. That would be your best case scenario. That would be your best course of action if you're in a car. You're almost never going to survive a tornado in a car.
That's the kill spot.
It's a kill spot. Yeah, that's a pretty deadly situation.
Is it better to be in a car, or like if you're out in a field and it's either you lying on the ground or you being in your car? Is the car the safer bet?
Go to the field.
Go to the field.
Yeah, car is a death trap because cars will roll. The tornado will just roll it across the ground for hundreds and hundreds of feet, and the car's just gonna crumple. And you're gonna be smashed. Yeah, there's all sorts of, or it could be picked up, and tossed. It's cars.
Or just death traps in general.
They just get mangled in tornadoes. Yeah, it's not good. Yeah.
I would not have guessed that. I probably would have stayed in the car.
Yeah, nobody wants to get out because you feel like you're safer in the vehicle.
You feel vulnerable.
Yeah, if you feel exposed outside the vehicle, but if the tornado actually encounters the vehicle, you're probably gonna die. Yeah.
Go to the field.
Go to the field. A ditch. A ditch would be the best bet. Some low spot, some spot that maybe debris will kind of pass over you, instead of. You're going to get pelted by small little pebbles, sand, dirt, whatever's being picked up by the tornado and accelerated across the ground. It's going to be like a shotgun, blasting you. So you kind of want to get below the wind level, in a low point, sort of a spot that kind of dips below the horizon like a ditch.
And so that would be favorable just because you're not getting everything that's thrown around in the wind coming at you.
Yeah, all the debris.
Is that what gets most people?
Yeah, debris is a big killer as well.
Yeah, I think even if you have a small little rock being, swirled around at 300 miles per hour, if that hits you, you're gonna feel it.
Yeah, you're gonna feel it. Yeah, that would not feel good.
Yeah, that would be painful.
Yeah. Yeah, I guess those are probably the two big killers: debris and cars and tornadoes. Yeah.
So you go from researching all these tornadoes, and then in your free time, you're like, I'm going to go hike some mountains and just kind of clear my head.
Yeah, I like the challenge. It's more the mental challenge in addition to, it's great physical exercise, but it's always fun to figure out, a route up a mountain. It's just interesting. I'm always bored, down in the forest, but once you get up onto the rock, and figure out how to get around these obstacles, I enjoy that. Things like Mount Rainier Mount Rainier is very obstacle filled endeavor. I like those two aspects, the physical challenge and the mental, interesting mental puzzle of it all.
Key being the challenge aspect, right? You're not just hiking up Patrick's Point on the weekends.
Right. Although I love it around here. I do a lot of trail running, and the trails around here are great. Prairie Creek is, an outstanding place to go trail running. It's just, again, kind of an obstacle course, going around these gigantic redwoods, going up and over ones that have fallen. There's lots of streams that you have to cross and terrain to, go up and down over.
Are you primarily picking hikes where it's the challenge in the actual hike, or are you bouldering or rock climbing as well?
I used to do a lot of that in Oklahoma. I haven't done much of it at all out here in California. Although there's a lot of good spots to climb. Some sea stacks, located along the beaches and places like that seem pretty fun.
But I mean, you're getting into some hectic situations sometimes, right? I was reading one of your blog posts and you were up on, I think it was Mount Hood or something, and you were talking about how there's zero visibility, and I'm looking at the pictures and there's just an insane amount of snow, and you're like, yeah, I'm gonna go hike this today.
Yeah, there's a lot of weather that is kind of miserable at times, especially during the spring when Mount St. Helens has been the worst for me. Going up that, I've had so many bad weather experiences on that mountain. It's just a lot of miserable, early to mid spring Pacific storm system moving on shore leads to it's wet, cold, ice. Pellets are flying around.
Are you
And then
picking those times because it's going to be miserable, or are these storms just moving in and you've already made the decision you're going to do it?
Yeah, I kind of already made the plan in advance, and why not give it a go, see what happens. But yeah, Mount Rainier is probably the most intense, close to death experience that I've had on a mountain. We summited kind of late, so that means we went back down as things were getting hot during the day. And we had to cross below a serac, which is a giant hanging wall of glacier, basically. And the serac released and sent massive blocks of ice down the mountain, right past the point where we just crossed. And after that, an avalanche was triggered. So we survived that, but then, like an hour later, we were approaching a crevasse that we had to jump across. And I stepped just off to the side, maybe a foot, and I punched straight through a hidden crevasse. I was going down if it wasn't for my other leg catching, more solid ice. So yeah, lots of things that almost got us. We just got lucky.
Yeah, that would be enough for me. I'd probably hang up my shoes. I'd be like, I'm done. I've
Yeah.
got the experience out of it that I needed to.
Yeah, I'm definitely not out there looking to encounter these near-death experiences. That's not the type of mountain experience I want.
Yeah,
So,
you want the challenge without the possibility of dying.
Yeah, there's always some possibility, random things happen, but
Well, even just going on a hike in the woods, there's the possibility that
a mountain
you could
lion,
get lost, or a mountain lion, or
that's probably the thing I fear the most is mountain
mountain
lions.
lions.
Although, yeah, who knows how many you've walked past and not even known it.
I wasn't even. I mean, you're always aware of mountain lions and you're aware of bears, and it's kind of in the back of your head. But I saw a video a couple weeks ago of this guy who was on a rock face, and this bear was trying to get him and his friend, and it's making passes on this rock face. They're hanging off, screaming at it, trying to kick it, and it's just clawing him. It's going after him. And I was like, yeah, that's now up on my list.
Yeah, I've encountered a ton of black bears. It's always been a positive experience. But I know there are cases where, the bear might have an injury and that makes it aggressive, or it might be starving.
Or you're passing by its cubs, and then you get between a mom and its cubs, and it's game over.
Yep. So there's always that potential. It can never be ruled out. Yeah.
Well, and you're up in Alaska, too. I would be worried about grizzly bears coming across my path. Or in Canada.
Yeah, I was in Juneau for a couple years, and Juneau's kind of right on the southern edge of where grizzlies were, located. They kind of stay away from the humans, so they're farther out in the wilderness. But there's been a few cases where they've been observed, near Juneau, and I've hiked through some of that area. There's also wolves out there that I've hiked through, their territory. But again, I think, for the most part, those animals try to avoid people. But again, life is random. You never know if something could go wrong. But maybe the probability is low enough that you don't have to worry about it too much.
Yeah, that's kind of a double-edged sword, right? Because the probability is low, but it only has to happen one time.
Yeah.
And you're like, oh, not great.
Yeah. exactly.
Do you have any desire to do like K2 or Everest, or those are kind of, you're not really
Um,
inclined to go down that route?
they're very expensive, and Everest is, tens of thousands of dollars to partake in, and then it's a complete zoo. I'm sure you've heard about the long lines of people going up the mountain,
That's
approaching.
what worries me. Is it might not even be you dying because something happened, but you could freeze to death waiting in these
Yeah,
insane lines just to get to the top, and you're walking past people who are dying on the side of
yeah,
just this cliff face.
yeah, yeah. So it
Not
doesn't
interested.
doesn't sound like something I'd be interested in.
How are you picking your hikes? Because I know, were you in Switzerland recently doing some
Yeah, a couple of
hiking?
weeks ago, we wanted to do the Matterhorn and then also the west flank of the Eiger. The Matterhorn was canceled due to weather. Storm system was moving through, and we just didn't. It wasn't worth the chance of, going up on that mountain where it's hard to get off of quickly if a storm, hits you. So we gave that one up, and then we did attempt the Eiger. We got up pretty high, but we ran into a cliff that we couldn't get around, so we went back down. But it was still cool. It was,
Is this how you're structuring most of your vacation time? Is around hikes that you'd like to do?
yeah, for that one. I mean, I've never been to Europe, so it was sort of a multifaceted trip. I really enjoyed the culture in addition to the mountain hiking, and the food was amazing. I embarrassed myself many times trying to communicate. My French was horrible, and they let me know that. But it was still a great experience.
Oh, that's awesome.
Yeah,
Yeah, when you're abroad, if they know you're American, especially, they're not afraid to let you know how they feel.
yeah, yeah.
I think that's
Exactly.
pretty standard everywhere.
Yeah, yeah. Have you traveled much?
I've gone
overseas?
to Canada and Mexico.
Yeah,
And Mexico, they're not afraid to dig in a little bit if you're a tourist.
yeah.
Have
That's
you
cool.
have you always been interested in these pretty strenuous hikes? Are these multi-day hikes for you, or you try to keep everything within a 24-hour period?
Just about everything I've done has been
24 hours.
day. Yeah,
Okay.
24.
That's probably the way to do it. Then you don't have to worry about packing in a ton of gear. And
Yeah, I like going fast and light. That's sort of just it's more enjoyable.
then it makes this suck a little more finite. Okay, I can get through this 12-hour period and just endure, and then I can go home and it's gonna be fine.
Exactly. You got beer and pizza waiting for you after the whole thing. So it's good motivation.
Yeah, that helps.
Yeah.
I'd noticed you did a section of the PCT, right?
Yeah, just little bits of it. Yeah,
Have you ever thought about doing the whole thing?
that'd be pretty awesome.
That's
And
talk about a long suck period. That's up
Yeah.
there.
Yeah, Appalachian Trail would be another good one. In Europe, they have what's called the Tour du Mont Blanc, which is like about 100-mile trek around the Mont Blanc Massif, and it's basically going from village to village every day, and it's like 10 to 15 miles between each one. That'd be pretty cool. PCT would be a whole different.
That'd be a different beast.
Yeah,
My
Yeah.
sister did the Camino de Santiago out there and loved it. And you're just going from hostel to hostel, checking out the architecture and visiting these cities.
I think that'd be ideal. Yeah,
That would be a fun way to do it, because then you're not hiking up the side of a mountain.
Yeah, and what they have going on in Europe, it's great. Everything's connected by a trail. Each village, each community, so you can pull something off like that and live, a fairly luxurious lifestyle at the end of each day. You got a hot meal and maybe a beer to drink at each village. There's usually shelter available, or at least a convenient place to set up a tent and take a shower. It's much more rugged out here. Like the PCT is, you're pretty much on your own.
PCT is rough.
Yeah,
PCT is a trek.
yeah. So yeah, I like the trains of Europe. You can go anywhere in Switzerland on a train. You can go from the airport to, like the Matterhorn within a few hours on a train. each one of those valleys is connected. I wish we had that out here.
It's crazy how interconnected they are with their rail system, and then you cut to us, and it's it's non-existent basically.
Yeah, I guess we're just too spread out here in the U.S. Maybe to pull something like that off. I don't know.
Which you would think would be the more the reason to do it is then you could connect these major cities through some, fast rail system, and then you wouldn't have to fly. It would ease flights, and then just kind of change how we travel in this country. But I don't know if people want to do that.
We love our cars. Yeah, but if we had a rail system like we had in Europe, I would use the rail here all the time. It'd be great.
It seems like that's really only a thing back east, and mainly like in New York, where they're really fans of the rail system.
Yeah, I think you're right.
Cut to any other state, they're like, no, I'm not riding the train.
Yeah, I can't do that in Nebraska.
Yeah. I mean, we have the skunk train up here, and that you're not going anywhere.
Yeah. Yeah, it's just if you got, a little time, it's just a nicer way to travel, and you meet interesting people, and you see, maybe you get a deeper feel for the area that you're going through. It's more of a experience than hopping on a plane and going through security and then sitting basically in a box for a few hours.
Yeah, crammed, breathing the same air as everybody. Yeah. Trains are definitely the way to go if there's the option for it. It might be a little slower, but
right.
At least you have some space to spread out. You can actually see the countryside as you're moving through it.
Yeah, I liked it. Yeah.
Okay, well, Jonathan, thanks for doing this, man. I appreciate you coming on and talking with me.
Thanks for having me on.
Yeah, we'll definitely have to do it again.
Yeah, that'd be great.
Do you want to plug all of your stuff, where people can find you, where they can find your blog if they want to check it out?
It's called Slog Alpinismo.
Great name, by the way.
Yeah, just sort of playing off a blog, but slog is, a long, arduous trek, basically. So that's the blog, and then there's also a YouTube channel and an Instagram, but it's really, it's a journal, pretty low key, and if people want to check it out, that'd be great.
Yeah, pretty low key, but dating back for a long time. I mean, you got it's a really cool little archive of these places that you have been, and the shots are awesome.
Thanks. Yeah, appreciate that.
Yeah. All right. Well, hopefully people will